Hello everyone, once again this is Peter from Learnwithuncletee and you are welcome to this tutorial. Now in this tutorial we're going to be discussing approximations from application of differential calculus. So let's dive straight into it. Approximation. Approximation. Okay, so basically it still goes with your primary definition of what approximation simply means. That is a value that is in close relation to your final value. So for example, if you are to approximate 2.31 to a decimal place, you say 2.3. So 2.3 and 2.31, the error that you have between those two should be, I think, 0.01. So, but you discover that the values are a bit close, and that's what approximation simply dwells into. So, how do we now relate approximations to differential calculus? Our gradient, which is our m, is defined by our change in y2 minus y1, which is being divided by x2 minus x1. So mathematically, our gradient is equivalent to our change in y, because y2 minus y1 is the change in y, which we represent as delta y in maths, divided by our change in x, which we represent as delta x. So the concept of approximation in differential calculus is that delta y over delta x will be approximately equal to your derivative, which is the y dx. So this what serves as the basic formula that we're actually going to be applying in this particular subtopic. So let's dive straight into a question so that you discover that how does this application now relate to our common mathematical calculations that we have. Now let's take down this question. The question says that if if a side of a square increases by 0.5%, if a side of a square increases by 0.5%, comma, find the approximate percentage increase in the area. Let me take the question again. If a side of a square increases by 0.5%, find the approximate percentage increase in its area. Find the approximate percentage increase in its area. So let's represent that mathematically. Let's draw a square first. So let's assume that this is our square, our very innocent square. Okay. Now, one of the properties that of a square, or let me say the most important property of a square, is that all sides are equal. So now, if we decide that from, okay, let me use a dimension sign so that you understand better. If we decide that the distance from one end from here to here is p, it means that this side will also be p, this side will also be p, this side will also be p, which gives us a perimeter of 4p. So all sides of a square are equal. Now, read the question again. The question says that if a side of a square increases by 0.5%, now I'm going to get here, but let's define something first. We are looking for the approximate percentage increase in the area. So firstly, you need to understand what is the formula for area. Area of a square is defined by the formula L raised to the power of 2, where L represents the length of one side. It means in this question, our area will give us P raised to the power 2, because the length of one side, we have taken it to be P. Now we have defined the area to be equal to p raised to power 2. So from here, you will discover that, okay, before I go to, or let me just differentiate it. We can differentiate our a with respect to p here, dA dp. If we differentiate p square, we are going to get 2p. Now let's cycle back to the question. The question said that if a side of a square increases by 0.5%, what that simply means is that the ratio of the change in the side of the square with respect to the original, that's the original length of that side, is actually equivalent to zero point 0.5. When you hear the word increases, it will be positive 0.5. So, but assuming they said it is decreasing, you will have to attach a negative sign. So, we are also going to do an example that's going to involve that. Now, the side of the square here, we have represented it as p. So it means that change in p will be theta p. In respect to the original, which is our p, is now going to be equivalent to 0.5%. So since it's increasing, we'll say plus 0.5%. And we know that 0.5% will be 0.5 divided by 100. So basically, we can represent that as a normal fraction. 0.5 over 100 will automatically give us 1 divided by 200. So let me just write that as 1 divided by 200. So now let's come back here. We will now apply the general formula for approximation. In this case, we have dA dP. So the approximation formula here will now be dA, or don't let me start with dA. Let me use the same format that I used. Delta, you know that the formula I gave you was delta y over delta x will be approximately equal to the y dx. So in this case, if we are using a and p, delta a over delta a over delta p will be approximately equal to dA dp. So this is where we're actually going to start our calculation from. So now you are going to understand better what we are doing now. So now let's start. If delta A over delta P is equal to dA dP, what it means is that delta A will be equivalent to dA dP times delta P. Okay, now before I go to the next step, one thing you need to notice is that what are we looking for? We are looking for the approximate percentage increase in the area. Don't forget, when I said the increase in the side was increasing at this rate, which was delta P over P, it means that the increase in the area is going to be what? Delta A over what? A. So if the increase in the area is delta A being divided by A, the percentage increase in the area will therefore give us this value now being multiplied by what? 100%. So most times we will now put an absolute value here because we want our percentage to be a positive answer. Because when you have the case whereby it is decreasing, you can get your, let's say, delta A over A to be a negative answer. So, but that's where the absolute value comes into play, because the absolute value of a negative or a positive number will always be the positive value of that particular number. So now, this is what we are looking for, the percentage increase in the area. We need delta A over A before we multiply by 100%. Now go back here. Here we have delta A is equal to the ADP times delta P. For us to find, or for us to get delta A over A, what the only thing you can do mathematically here is to divide both sides by a. If you divide the left hand side by a, you must also divide the right hand side by a, and that is where the technique comes into play. So it means that theta, if I divide both sides by a, we are going to have theta a being divided by a is equal to dA dP times theta p. We're also dividing this side by a. So you can decide to say dA dP times theta p, everything divided by a. When you take your division sign, converting it back to multiplication sign, you are still going to get something like times 1 over a, which will eventually still bring you this. So, but mathematically, you can actually understand here, once we introduce an a here, we have to introduce, because this is multiplication, if this a cancels this a, the equation remains the same, which makes it possible for you to solve. So now, we now have theta a over a. We leave it and we solve everything that we have at the right hand side. So now let's solve. Theta a over a will now give us our dAdP. We have gotten our dAdP to be what? 2p. So this will give us 2p times theta p divided by our a. Don't forget, our a is equivalent to what? P raised to the power of 2. P raised to the power of 2. So it means that theta a over a will now give us p in p square will remain p. So we'll now be left with 2 times theta p over what? Over p. So now you see that we have been given theta p over p in the question to be 1 divided by 200. So it means that we have 2 times 1 over what? Over 200, which will give us our theta a over a. Okay, so now 2 times 1 over 200 is going to give us 1 over what? Over 100, because 2 in 200 will give us 100. So we'll go back to this formula. Therefore, our percentage increase in our area will give us the absolute value of our theta a over a now is what? Is what? 1 over 100 times 100%. Our percentage increase in our area will give us the absolute value of 1 over 100 is still what? 1 over what? 100 times 100%. So therefore, our percentage increase in area will be equivalent to 1%. So our percentage increase in area is 1%, and that will be the final answer to this question. So basically, what you need to understand in approximation is the general formula, which is theta y over theta x will be approximately equal to dy dx. Then you just change your independent and your dependent variable based on what you have been getting in this question. You discover in this question p serving as our independent variable, a serving as our dependent variable. So we are going to take another question now to solidify our understanding of this particular subtopic before we bring the tutorial to a close. Okay, now let's take another question. If the radius, you can write, if the radius of a sphere, decreases by 0.1%, if the radius of a sphere decreases by 0.1%, find the percentage decrease in the volume. If the radius of a sphere decreases by 0.1%, find the percentage decrease in the volume. Question again, if the radius of a sphere decreases by 0.1%, we have to find the percentage decrease in the volume. So this is a graphical representation of a sphere. Now let's solve the question. Now, one of the first things you need to define are your formulas. So that's why application of differential calculus cuts across a lot of topics. You discover that we, under the equation of tangents and normals to the curve, we discussed remarks based from straight line under coordinate geometry. Now you discover that under approximations, now we are dealing with measuration formulas. You need to know volume of solid shapes. That's a lots of them. So let's define the formula first. We want to find the percentage decrease in the volume. So we need to know what is the volume of a sphere. Volume of a sphere is defined by the formula 4 over 3 pi r cube. If you are dealing with volume of an hemisphere, so this for sphere. If you are dealing with volume of an hemisphere is half of this, which will be 2 over 3 pi r cube. So that's volume of an hemisphere. For surface area of a sphere is defined by the formula 4 pi r square. While surface area of an hemisphere will be 2 pi r square. So this for sphere, this for an hemisphere. Okay, so but basically here is this first formula that we just need. Now, read the question again. If the radius of a sphere decreases by 0.1%, the radius, so it means our change in the radius to the original radius will be equal to, hear the word, decreasing. So that will be negative minus 0.1%. So it means our change in r over r will give us minus 0.1 divided by 100. And minus 0.1 divided by 100 as a singular fraction is automatically going to be 1 over 1000. So this will give us 1 over divided by 1000. So let's go straight. Our volume formula again. Our volume is 4 over 4 divided by 3 pi r cube. dVdr will differentiate with respect to r. dVdr will give us 4 over 3 times 3. That will give us 4 pi r square. So from approximation, change in v over change in r will be approximately equal to dVdr. So here what it means is that change in v will be equal to dVdr times delta r. So if you divide both sides by v here, you are going to have delta v over v is equal to dVdr times delta r over what? Over v, because we are dividing both sides by v. So now, what it means here is that delta v over v will give us, our dVdr is what? 4 pi r square. So we have 4 pi r square times delta r divided by, our v is what? 4 pi r cube divided by what? Divided by 3. So delta v over v will give us, the reciprocal of this automatically will give us 3 times, that's reciprocal of this, is this 3 that is coming here. So 3 times 4 pi r square times delta r divided by 4 pi r cube. So here what it means is that delta v over v will give us 3 times 4 cancel 4, pi will cancel pi, r square and r is power 3. We'll be left with delta r over what? Over r. So our delta v over v, that is minus 1 over 1000. So this is 3 times minus 1 over 1000, which is going to give us minus 3 divided by 1000. So if you go back to the question, we are looking for the percentage increase in the volume. The percentage increase in the volume will therefore give us our percentage increase in percentage decrease in the volume, sorry, will give us delta v over v, that's the absolute value, multiplied by 100%. So our percentage increase in our volume is going to give us the absolute value of minus 3 divided by 1000 multiplied by 100 multiplied by 100%. So our percentage increase in our volume is going to give us minus 3 divided by, Okay, the absolute value that will give us plus 3. 100 in 1000, that will remain 10. It means our percentage increase in our volume is going to give us 0.3%. So for this question, our percentage increase in volume will be 0.3%, and uh that will be the final answer to that question. So see you in the next tutorial.